This lesson, we're going to learn how to use the remainder theorem to find the remainder without dividing. So now, let's do some investigation to figure out what remainder theorem is. Part A. Let's divide x squared minus 7x minus 10 by x plus 3. So first, let's write the division symbol. Next, write the coefficient of the dividend inside the division symbol. Then, we'll look at the divisor. The coefficient here is 1, so we don't need to factor any numbers out. And ignore the first term. Now, take the opposite sign, which is a negative 3. Put on the left-hand side of the vertical line of the division symbol. And now, we are ready to do division. First, let's bring the 1 down. And you do 1 times a negative 3 will give you a negative 3. And you add negative 7 and negative 3 up to get a negative 10. And then you do negative 10 times by negative 3, you get 30. And you add negative 10 to 30 to become a 20. Since there's only one term for the divisor, that means there's only one term for the remainder. So 20 is our remainder. Let's make a division statement as a conclusion. So we say the dividend x squared minus 7x minus 10 equals to the divisor, which is x plus 3, times by the quotient x minus 10 plus the remainder, 20. Now, let's take a look on the right. Given fx equals x squared minus 7x minus 10, we want to find f at negative 3. That means all the x has been replaced with the value negative 3. And we're going to have 9 plus 21 minus 10, which is 20. And that is the remainder we find from the synthetic division. Let's do part B. First, do a division symbol. Next, write the coefficient of the dividend, 1x cubed negative 7x squared negative 4x positive 36. And x minus 2 means we're going to put 2 on the left-hand side of the division symbol. Now we are ready to do synthetic division. Bring down the 1. 1 times by 2 is 2. Negative 7 plus 2, negative 5. Negative 5 times by 2, negative 10. Negative 10 plus negative 4, negative 14. Negative 14 times by 2, negative 28. 36 minus 28 will become 8. One term for the divisor, one term for the remainder. Now let's make a division statement. We say x cubed minus 7x squared minus 4x plus 36 will become the divisor, x minus 2, times by the quotient, x squared minus 5x minus 14, plus the remainder, 8. Let's take a look on the right. So given fx, and we want to find f at 2, that means all the x has been replaced with a 2. Now we're going to have a minus 28 minus 8 plus 36, which is 8. Once again, this is actually the remainder that we find from the synthetic division. Let's do 2 more investigations before we finalize what remainder theorem is. So let's do part C. First, you write a division symbol. Next, write the coefficient of the dividend inside a division symbol. Now, because our divisor is x minus 5, ignore the first term. We put the positive 5 on the left-hand side as our divisor. Now we are ready to do division. Bring down the 2. 2 times by 5, 10. Add 3 and 10 up, 13. 13 times by 5, 65. Add negative 4 and 65, you get 61. You do 61 times by 5 is 305. Add 3 and 305 up, you get 308. One term for the divisor, one term for the remainder. And now let's make a conclusion. Dividend equals to divisor, x minus 5, times by the quotient, constant, x term, x squared term. So 2x squared plus 13x plus 61 plus the remainder, 308. Now, let's take a look on the right. Given the fx, now we have to find f at 5. That means all the x has been replaced with a 5. Then we're going to get 308 again. So once again, this is 308 is actually the remainder from the synthetic division. Part D. First, write the division symbol. Next, you write the coefficient of the dividends inside the division symbol. Then, because this divisor has a leading coefficient of 2, so we have to factor out a 2. So first, let's write the divisor on the side. Then, we're going to factor out a 2. Then, it becomes x minus 5 over 2. That means on the left-hand side of the division symbol is going to be a positive 5 over 2. Now let's do division. First, bring down the 2, and we do 2 times by 5 over 2, you get a 5. Add 3 and 5 up, you get an 8. And 8 times by 5 over 2, you get 20. And you do negative 4 plus 20, you get 16. And 16 times by 5 over 2, you get 40. And you add 3 and 40 up, you get 43. 1 term for the divisor, 1 term for the remainder. So 43 is our remainder. However, this is not our real quotient yet, as our divisor has been increased by 2 times more. That means our quotient needs to be 2 times less. That means those 3 numbers needs to divide by the leading coefficient of the divisor, which is a 2. So we're going to get 1 and 4 and 8. And now let's make a division statement. Our dividend equals the divisor 2x minus 5 times by the quotient x squared plus 4x plus 8 plus a remainder 43. Now let's do the calculation on the right. So given the fx, now we want to find f at 5 over 2. That means all the x value has been replaced by 5 over 2. And let's expand and simplify. We also are going to get a value of 43, which is a remainder resulted from the synthetic division. Now, let's go back to part C again and pretend we did not do any division. Then our division statement will look like this. Dividend equals to divisor x minus 5 times by the quotient qx plus the remainder rx. If I want to find the remainder without doing the division, that means I want this part to become a 0. However, I have no idea what quotient is, so the only one I know is the divisor. So if the divisor becomes a 0, and 0 times by anything will become 0, then this will just left me with a remainder. So we say, let x minus 5 equals 0, then x will become a 5. Then let's substitute 5 into the x into the division statement. Then we're going to have this. Then we know 5 minus 5 will become 0. This entire thing becomes 0. So on the right-hand side, you're left with a remainder. And the left-hand side, this calculation is actually the same calculation here, which is 308. So we can get the remainder without using the division. Let's look at part D. Once again, pretend we do not do division yet. Our division statement will be dividend equals the divisor 2x minus 5 times by the quotient qx plus the remainder rx. And since I want to find the remainder without using division, and we have no idea what the quotient is, therefore, we have to let 2x minus 5 to become a 0. Then we get x equals 5 over 2. If we substitute 5 over 2 into the x into the division statement, we're going to end up with this line. And on the left-hand side, this calculation will end up to be a 43, as we can see on the right-hand side. So left-hand side equals a 43. And the right-hand side, because 2 times by 5 over 2 minus 5 will become a 0. And 0 times by anything will become 0. So this just becomes our remainder. Now, let's make a conclusion for our remainder theorem. If a polynomial fx is being divided by x minus a, we let the divisor equals 0. We find the value of the x is going to be a. We substitute a into the function. It will become our remainder. So, therefore, our remainder is f at a. Next, if the function fx is being divided by ax minus b, so we let our divisor ax minus b equals 0. That means ax equals to b divided by a on both sides. X will become b over a. So our remainder will be f at b over a. Now, let's use the remainder theorem that we learned to find the remainder without dividing. So example 1, if I want to find the remainder when the function is being divided by x plus 6, the first thing is we have to let the divisor equal to 0. So x will become negative 6. So our remainder will be f at negative 6. Substitute and expand and simplify, you're going to get negative 76. Once again, for part B, in order for us to find the remainder, we have to let the divisor equals 0. So 2x minus 3 will become 0. That means 2x equals 3. That means x equals 3 over 2. So our remainder will be f at 3 over 2. Substitute in and expand and simplify, you're going to get 3 over 2 as the remainder. Example 2, there is a function given, and the function is being divided by x minus 5. The remainder is 15. We want to find the unknown variable k. So step 1, we have to let the divisor equal to 0. So x minus 5 equal to 0, so we know x equals to 5. Step 2, we're going to use the remainder theorem to find the value of k. So we know the remainder will be f at 5. And since the remainder is given, so we know the remainder is 15 equals to f at 5. That means we put 5 into every single x for the function for fx. Then we can expand and simplify. We get 5k equals 195. Then k will be 39. Example number 3, a function fx is given. However, inside the fx, there are two unknown variables, a and b. So that's why they gave us two more information. It says when you divide it by x minus 1, the remainder is 6. When you divide it by x plus 2, the remainder is 15. We want to find the values of a and b. So first thing we do is we let the divisor equal to 0, x minus 1 equal to 0. That means x equals to 1. Using the remainder theorem, we know the remainder will equals to f at 1. And we know the remainder is 6, so we substitute 6 into the remainder. F at 1, we substitute 1 into the x into the function fx. We expand and simplify. We got a plus b equals to 8. Next, we let the divisor x plus 2 equal to 0. Then we know x equals negative 2. Using the remainder theorem again, we know the remainder will be f at negative 2. But this time, we know the remainder is 15. So 15 equals 2. We put the negative 2 into the x into the function fx. That's expand and simplify. Now we get 8a minus b equals to negative 17. Now we can generate a system of two equations that's labeled in equation 1 and equation 2. By looking at those two equations, I notice equation 1 has positive 1b and equation 2 has negative 1b. That means I can use elimination to eliminate the b. So I'm going to do equation 1 plus equation 2. So a plus aa, I get 9a. b plus negative b, you get 0. And 8 plus negative 17, you get negative 9. Therefore, we get a equals to negative 1. And substitute a equals negative 1 into equation 1, we will get b equals to 9. Therefore, a equals negative 1, b equals to 9. If they ask for fx, then fx will be negative x cubed minus x squared minus x plus 9. Example number 4. We are going to find the remainder using 3 different ways. First one, we're going to use long division. Second, we're going to use syntactic division. And third one, we're going to use remainder theorem. That means without any division. Method 1, using long division. First, we draw the division symbol. Then we fill in the dividend and the divisor. And now we are ready to find the quotient. We always use the first term of the dividend to divide it by the first term of the divisor to get the quotient. So x to the power 4 divided by x squared, we're going to get x squared. And please remember to line them up. That means we have to put the x squared on the x squared column. Then we multiply the divisor by x squared to get the next line. Now we subtract those two lines and bring down one more term, x. Then we repeat the process. X cubed divided by x squared, we're going to get an x. Then we multiply the divisor by x. Then we subtract those two lines. We bring down one more term. And you do negative 4x squared divided by x squared. You get negative 4. Now, you multiply the divisor by negative 4. Then you subtract them. Now we have the remainder, 7x minus 5. Method 2, that's using syntactic division. So first thing we do is draw a division symbol. Next, we fill in the coefficients of the dividend. So 1, 2, negative 5, 1, and 3, coming from the coefficients of the dividend. Next, we have to fill in the divisors. So first, we have to check the leading coefficient of the divisor, which is a 1. That means we do not need to factor any numbers out. Then we ignore the first term. So this is a positive 1x, positive 1. Then we're going to fill in a negative 1. This is negative 2. We're filling a positive 2. And now we are ready to do division. First, bring down the 1. And we do 1 times by negative 1, you get negative 1. And you do 1 times by 2, you get a 2. But this time, that's 1 degree lower, so we have to push 1 space to the right. Then we're going to add those two numbers up. 2 plus negative 1 will become a 1. And then we do the same thing. 1 times by negative 1 and 1 times by 2. So we're going to get negative 1 and 2. And now we're going to add those three numbers up. So negative 5 plus negative 1 plus 2 will be negative 4. Then we do negative 4 times by negative 1 will become a 4. Then we do negative 4 times by 2 will become negative 8. Once we reach the last corner, then we stopped. Then we just add all the numbers up. So 1 plus 4 plus 2, it becomes a 7. And 3 plus negative 8 will become negative 5. Since there are 2 terms for the divisor, that means there are 2 terms for the remainder. So therefore, our remainder will be constant term, x term. So we write 7x minus 5. And the first three numbers is our quotient. So constant term, x squared term. So our quotient will be x squared plus x minus 4. Method 3, we're going to use remainder theorem to find the remainder. So first thing we do is write down the division statement. So dividend equals to the divisor times by the quotient qx plus the remainder rx. Then we can factor the divisor into 2 linear factors, which is x plus 2 times by x minus 1 times by the quotient plus the remainder. Now, since the degree of the divisor is 2, then the degree of the remainder at most is going to be degree 1. So we write ax plus b. Once again, if we want to find the remainder without using division, that means we want the product here to be a 0. That means x plus 2 will be 0 or x minus 1 will be 0. That means x could be a negative 2 or x could be a 1. Let's substitute x equals negative 2 into the division statement. So we're going to get to this line. Then we're going to expand and simplify. Now we have negative 19 equals negative 2a plus b. That's labeled in equation 1. Then we are going to substitute x equals to 1 into the division statement. And after we expand and simplify, we're going to get 2 equals a plus b. Now that's labeled in equation 2. By looking at those two equations, I noticed they both have a positive 1b. That means I can use subtraction between the equations to eliminate the variable b. So I'm going to do equation 1 minus equation 2. Now I get negative 21 equals negative 3a, so a equals 7. Substitute a equals 7 into equation 2. Now we get b equals negative 5. Therefore, we know the remainder will be 7x minus 5.